So it hit me that I've done a lot of talking and not a lot of coding, and coding is where you can engage with what's going on here. So there's more I want to talk about with the perspective projection matrices, but I think it's time to actually do some code so that you can engage. The example we'll do is very simple. It's very similar to what we've done before. I want to place a box or a cube into the scene. I want to translate that cube in the negative z direction, translate in the negative z direction, and translate simply means move. And the reason I want to go in the negative z direction is because the camera is looking down the negative z axis. Again, this is OpenGL, right-handed coordinate system. And then once we have our cube or box in front of the camera, then I just want to smush it like we've done before by doing the perspective projection matrix. And then once we're complete, the scene we should see is something similar to what I'm showing you here. Not perfectly like this, but similar to that. There's a few steps we need to do before we'll actually have this scene up in our own windows. If you recall this diagram I made several videos ago, we send our vertex attributes into the vertex shader. We don't have any vertex attributes for a three-dimensional cube, so I'll show you those and show you how to get those into your vertex shader. The vertex shader has to output a position in screen space, or in projected space to be perfectly technically correct. And there also has to be that z depth. We've talked about depth, but we're generally looking for an xy so we know which fragments to fill in. The hardware will use the XY to know which fragments to fill in and execute our fragment shader, interpolating the data into the fragment shader. So I need to give you some vertex attributes for a cube. We also need a math library. Obviously, if we're going to use matrices, we need a math library. We're not going to write one. If you want to write one, follow my game engine programming playlist. I do such in there. And I also need to teach you about shader uniforms so that we can set our matrices into our shaders so our shaders use this matrix data. So that's where we're going. Let's get back to our code and actually make that happen. So first thing we need to do is get a math library and make it accessible in our project. I actually noticed I have the math library already there in mine. I can't remember in the first videos if we added it or not, but I'll show you how to do that. I'm using the GLM OpenGL math library. Google that. We have OpenGL Mathematics. Click on this. And there's a downloads right here. Click on downloads. Download the latest, unzip it, put it in your middleware folder. If you remember, I have my middleware folder handy right here. Remember, we created this in one of the first folders. We created our project in the graphics pad folder, but then we added this middleware, and we had glue and Qt. I already had GLM, but you'll unzip GLM right here for your convenience. I guess you could put it anywhere you want to. One nice thing about GLM is it is a header-only library, meaning we don't need a lib, we don't need a DLL. It's all in headers, all the code's in line, which makes sense. It's a simple mathematics library, so it doesn't make sense to have a big fat lib and DLL hanging out. And then going back to our project, we'll click on Solution Explorer, right-click, and go to Properties. Right-click on the project and go to Properties. Bring this into View. In Configuration Properties in C++, click on General. Remember early on in the video playlist, we set these up. I'm going to hit the down arrow, click Edit, and see if we can get some more screen real estate there. We added the project directory middleware Qt, project directory glue, and then all we need to do, we could actually just copy one of these. Copy, Control C, double click, Control V. Instead of doing glue, I'm going to do GLM. I don't need to do /include because it's just a header file library and all the headers are located in a subdirectory of GLM. So I'll click OK, and then let's check out our pound includes. I believe I can say pound include GLM / whatever we want. Pretty much everything is located in glm.hpp. We'll find out with matrices some of the other transforms and those kind of functions. We have to include a few more files from GLM, but the bulk of it we can just get by including glm.hpp. HPP standing for header file. I guess PP is for C++. That's just the convention they chose for their file name extension. So we now have glue. We need cube data.